Hello and welcome back to Calculus 3. We are continuing to explore chapter 12, and today we are focusing on graphs and level curves. We first start with the definition of a function, which might be included as a statement on the exam. So, we know from pre-calculus and then calculus 1 that function is a rule which assigns to each x in a domain a unique y in the range. We know that. And we say that in a 2D world, which we denote as r squared, we have that y is equal to f of x. We graph that on xy coordinate system, and we have a point that it's x comma y containing two dimensions, dimension x and dimension y. Then into 3D world, I don't know what happened with the D. There we go, 3D world, which is denoted as R3, and now my function looks like this. Z is equal as a function of x and y, giving us a point x, y, z, which is all graphed on the x, y, z coordinate system. Moving into the 4D world, and then 5D and 6D and so on, you can denote it as r to the 4. But what's important here to understand is that we use the 4-dimensional all the time. Because now I can say, let's say w is a function of x, y, and z, which gives me x, y, z, w as a point. No graph. Or actually, no, you know what? I'm going to say this plus colors. That's how we do it. Now, an example of the 4D would be, let's say you have an object, right, which occupies 3 dimensions, such as this cylinder that I have in my hand, and let's say its temperature. So that would be the 4th dimension, the temperature, because temperature of this object can be expressed as a function. If I am to bring some flame on one end, I can still hold it here, because it will take a very long time for the object to heat up, so I can't hold it on the other end. So there is some kind of mathematical function that models that temperature change from the end where the flame was applied to the opposite end of the long object where you hold it. Which is why pots and pans have the long handle, right? Which doesn't get hot as much and as fast as the actual pan or a pot. So we have dimensions, they upgrade throughout, but what's important is to know that the one on the right hand side is always your range. It's always the, if you want to call it under quotation mark, the answer. And then you have the world of input, which is 1-dimensional domain, 2-dimensional domain, 3-dimensional domain. Because if I'm talking about the 4-dimensional function, 4th dimension being a temperature, I can pick a point inside this object which will actually have 3 dimensions, right? X, Y, and Z. And then the temperature at that point would be the 4th characteristic. So you have location in X, location in Y, location in Z, and the temperature on top. So we deal with these things all the time. Location, look at this. You are here, right? Congratulations, you made it to the class. Location, X, Y, Z, that's the classroom, and then time, T, at which you're here. So X, Y, Z, T. Ooh, space-time, right? That's what space-time is. It's just being somewhere at a particular time. You all work with that all the time. So now, if I am to understand these functions, I can quickly define once and for all that I can write the function in its implicit form as x, y, z, w, blah, blah, whatever else equals 0. To give you a 2D example, that will be f of xy equals 0. All of the mathematics you learned up to Calc 3 fall in that category. You have never had more than 2 variables. You always had only x and y. So if you have any kind of function or non-function gets to be in this set, your y equal 3x plus 7, the mx plus b, your y equals to 8, your y equals sine x, your y equal cosine x, but also your x squared plus y squared equals to 9, which is a circle. They all fall into that one notation there because all they have is x and a y. So any relation that you have between x and a y, only 2 dimensions, falls in that category and can be written as move everything to the left and make it equal to 0. So that's that. Now we have a 3D world, and in a 3D world we are going to write f of x, y, z equals 0. So your equation of the sphere and equation for this and that all goes, or any kind of shape, it all goes in the bag right there. So this is the implicit way to talk about this. Now, important is, again, this notion of domain. So this thing over here is the domain. Sorry, wrong function. Line z equals f of xy. We are going now into R3. We are considering R3. I was discussing R, so I just fix that. And we are considering this guy over here, which is our domain. Domain is R2. Domain has sets of points which are x and y in the xy plane. So what we are going to do here is we provide x and y, and then we are able to compute z. If you want a graphical representation, you have your good old xy plot, which you are very familiar with, and you are mapping that onto a z-axis. So the entire domain over here you pick a point, and that point maps somewhere. So this is the function f, and this over here is f of xy, and you have your input xy. But it's a z, so you can see that z is equal to f of xy from this diagram here. So pick any point in the domain, here, it will map onto z somewhere. If it doesn't work, well, it's not in the domain. The same thing like in the 2D case where you said square root of -7. Well, tough luck, no negatives under the square root. or ln of negative 7. Again, no negatives in ln. So now looking at this diagram, it reminds us of the diagrams that we've seen for functions before, except there was a x line mapping onto y line. Now it's xy plane mapping onto a single line. So now we write the definition of a function, which, as I said, might be featured on one of the exams to be stated as is, because it's crucial to know this. And again, I am going to write the same wording like I used before, so all of you who are following me since pre-calc 1, it's going to be easy. Function is a rule which assigns to each point xy from the domain a unique z in the range. So we are using x and y as the input, and then we are using z as the output. So a diagram for that: you have to feed x and a y, function will act and spit z out on the other end. You have the side for domain and side for range, which is input and output. So a quick example: z equals 3xy minus y squared. The most fundamental of all of these is compute z of 3, negative 1. Compute z of 3, negative 1. It's obviously just plug and pray. So 3 times negative 1 minus negative 1 squared. That's negative 9 minus 1, negative 10. The big part of this is a discussion about the domain. So what are we allowed to plug in? Well, you have to just be a little bit more careful, and you have to know the basic stuff from your pre-calculus class to navigate this easily. We are not interested too much with the polynomial and stuff, because we know that polynomial looking problems are all okay. All points are in the domain. Where we are more concerned is when you have ln around and the square root around and all of the denominators, because those make parts of function don't exist, or denominator equal to 0 means it's undefined, and so on. So a few of these cases, let's say, first of all, look at, say, f of xy is defined as the square root of 4 minus x squared minus y squared. Now you are supposed to solve this the same way you solve the ones back in your pre-calculus course, except now you just have to think a little bit more. You should know by now, since you are sitting in Calc3 class, that any domain that involves a square root, the first step is to take whatever is under square root and make it 0 or positive. So make it non-negative. So if you do that, you get this inequality, and then you work with this inequality, and then you flip this inequality so it's easier to understand. And what do you get? What is this? Circle with radius 2 and
Ball.
it's not a ball. It's this over here.
Everything inside.
Everything inside. Very good. We are talking about the domain. So you have a circle whose radius is 2, and everything inside, including the outside edge, is what you have as a domain. Now that means that any ordered pair, x comma y, that lives in this circle, you can pick those coordinates up and plug them in original problem, you will be able to compute. Pick 1, 1, it's in the region. You plug in 1, 1, you get 4 minus 1 squared minus 1 squared, working out to be square root of 2. Awesome, there's your answer, square root of 2. You pick 2, 0, it's gonna work. You pick anything that you want to pick, it will work as long as it's inside that green region, right? Including the edge. Pick anything outside of that circle and you don't get it. So you have to be a little bit careful. Now, this next problem is pretty much the same. Again, we are looking for the domain. But this time I want to say, how about x squared y times ln of xy? So let's say this is the domain we want to consider. When you are considering domains, you have to consider all of the functions that make up more complicated function independently and pick the most restrictive one of all. I like to explain this as, imagine you're running, after the train. You want to catch the train. It's moving very slowly out of the station. The doors are still open for whatever reason. Maybe they're broken. And if you run fast enough, you're going to catch the train. However, with you is your grandma. So now you have you have a choice to make. You either catch the train or you don't.
Well, how important is the train ride and how important is our grandma?
That's why it's the choice to make, individual choices around it. So now, for the domain is always going to be the domain of the most restrictive piece. So now I know that x squared and y go from negative infinity to positive infinity. The issue is clearly with ln of x times y. Again, you are in Calc 3. What you need to know from your pre-Calc 1 class 5 courses ago is that for ln, you take the argument and you make it larger than 0. You can't put equal because ln of 0 is negative infinity, undefined. So in this case, no equal like you had for the square root. So now this is it. It is x times y needs to be larger than 0. The product of the two needs to be larger than 0. So as long as you are picking up values that will make your value in ln larger than 0, you're good. This is actually the domain. This is your answer. Domain. Because you are not going to have any problems with x squared y in front. You can completely ignore that part. The ln is the one that causes issue here. And you focus only on that one. So ln xy is the one that we have to focus on. And you understand this domain that as long as the product of the x and the y is positive, we are good to go in terms of calculations. Now, how do you graph two-dimensional functions, three-dimensional functions, which is two independent variables x and y and the output variable z? Well, you all have a $1,000 gift in your email, that's how. Or you put some good graphing utility on your phone, you can do that as well. What I do to visualize and graph 3D functions is, if I don't have access to technology, that is I look at the graphs of how they look like as I set x to 0, y to 0, z to 0. Because I want to see how they look when I look at them sideways, or from the front, or from the top, depending on which one you set as 0. And then I know how these three look, you know, from three different perspectives, and then in my head, I just put them together, and I have the shape. So say that you are looking into z equals 4 minus x squared minus y squared. No square root. This is how I solve these problems in my head. I say z equals 0 gives me circle x squared plus y squared equals to 4. So looking from the top at the xy coordinate plane, I see that this 3D shape crosses through the floor, which is our xy because z is 0, leaving the circle x squared plus y squared equals to 4. What happens if I set x equal to 0? If I set x equal to 0, I get z equals 4 minus y squared. Well, in my yz plane, all I get is this. I get a parabola, and this is a yz plane. Parabola that starts at 4 on top and just drops down. Now, if I set y equal to 0, I can figure out that these guys go through -2 and 2. Awesome. And then I go y equals 0, which gives me z equals 4 minus x squared. And I get to draw identical graph, except now my x's are x and z. That's symmetrical. So now, in my head, I put these three shapes together. I see that if I cut the object through the x-axis or through y-axis, I get parabolas. And if I cut them z, right, horizontally, I get circles. So this must be paraboloid that goes from 4 opening downward, because if you just see how they work together, you can put it together and see. So now what I do is I draw paraboloid that goes from 4, that looks like a 9, so I'm going to fix that. It's a paraboloid that will go forever downward, and it starts at the top of 4. Now this takes a lot of practice, right, to be able to dissect things like this when you see the equation and graph them. Obviously there will be a very complicated shape here and there, which you can always use the software for, and Mathematica will be superior, because once you figure out how to graph these things, guys, you will be able to turn it and rotate and see it from different angles. So you make your x-axis visible, you make y-axis visible, you make z-axis visible to see how the intersection works. So we have to figure out, there's always something to figure out how to graph these things. And what you do is you do this cross section, but the most important part is to be able to read that graph, because today we can ask computer to graph anything, almost anything, and the computer will. But if you don't know how to analyze it, well, there goes your engineering. And homework is giving you some of these exercises to practice. Now, what happens if they say it's a three-dimensional object, but one of the variables is missing, x or y? What does that mean? Like, let's try to somehow figure out and visualize this. Z is equal to e to the minus y. So think about it a little bit. Yes. Talk to people about the problem, I mean. About the math problem. Be very specific. This one.
For the z equals 0, e sub negative y equals, then that would mean e to the negative y equals 0. Y equals negative ln 0, which can't be a thing. Oh, no, I won't. So you're saying along the x, do you mind answering my question? Sir, you were saying along the xy plane, there's nothing. Down and which plane is that? Why is it? Hang on, I gotta make my graphs. We only work the x, y plane because we only work in two planes at once, but we never really range them. I took animation I took 2 semesters in high school.
Okay, I heard the word high school, which does not include
Well, actually,
notes for this problem. So let's see how this problem works. So the only one that I can graph here would be this one, right? Going through one where this is your z and this is your y. Now x would go from the paper or your screen or the board going directly towards you, perpendicular to the surface. So that's why we don't see it. This is the YZ plane where x is 0. And the z is poking out towards your eyes, perpendicular to the surface. That's how x points out. X points out of the page or screen or whatever, right, towards your eyes. Now, since x is not mentioned in the equation, that means that x is taking on all of the values at once. So what this is the infinite skateboard launch ramp of this shape. So, yes. Can you lift that up so everyone can see? There it is, right there. You just bend the paper. So when you look from the side, you see exponential function. When you look from the front, it's just going to be infinitely wide ramp for skating or whatever. So look from the side, exponential function. Look from the front, infinitely wide, because x is not mentioned in the equation. To help you with that concept a little bit, I will again remind you that equation for the horizontal line is y equals a number. And then you will graph that. This is the first thing you learn how to graph. X equals, y equals, and what you get is this graph going through C. Observe that x was not mentioned anywhere. But when you look at the graph, x is taking on all of the values, all of them. So y is pinned to be whatever the c is, but x takes all of the values from negative infinity to positive infinity. So the same thing happens up there. If there is no x or there is no y, the graph would be a side shot of whatever you have and then extend infinitely in the variable, in the direction of the variable that you actually don't have mentioned in the equation. So if I am to create, now this is extremely important if you guys are going to make mathematical shapes to do engineering. You have to understand how you're going to program that in a computer to do the stress analysis or something. You have to be able to model these kind of things if you want to be engineers. So, if I am to just show you this shape now, you should be able, given the previous two problems, not including the line thingy, what is the equation of this shape? You look from the front, this is what you see. You look sideways, this is what you see. What is the equation? What do you have when you look at it this way? Negative what? Okay, call it negative y squared. You have a downward opening parabola. This way, you see something going infinitely far. Since you picked y, then we are stuck with this to be x. So what is the equation of this? Z equals negative y squared. You can shift it up or down by putting some kind of number. See that one? There it is, right there. So if it's at 4, or it starts at 0, or starts whatever. So whatever value you put where the 4 is, that's where the maximum of this shape is going to be. Flip it this way, you have the same thing. Flip it that way, you make it into a 4 plus or 0 plus x squared, no y. So as long as it stretches forever in one of the two dimensions, right, then you have. Now we can have, diffusion models. There's just so many shapes, and you just go and you try to figure out which one is which. Now I always like the problems where you get to match the shape with the equation. Those were my favorites. So I don't know if this is gonna work. Maybe yes, maybe no. No, still didn't fix it. Okay. I'm lazy to bring it up on the tablet now. So if you go to homework, you are going to find a problem. Well, actually 4 problems. No, it is 1 problem with 4 pictures and 4 equations. And they are asking you to match the shape with the equation. Spend time on that. Think about how they look when you cut x, cut y. Because guys, those are your jobs. That's what you will be doing. You will not be computing anything of this by hand, but if you can't match the shape, you can't program computer to do stuff for you. As I said, you will never integrate. After you take your last exam, you will never integrate for your work. You will never differentiate, right? You will never plug in a value into a function. So basically stuff that we spend 95% in class and homework, you'll never get to do as engineers. But this stuff is what you will be doing all the time if you are mechanical, structural, whatever, because you're designing things. And in order for a computer to do the analysis you need, have to be able to plug it in somehow. All right. One more concept in this lecture, and that is the concept of level curves. So a level curve is going to be the trace that you get as you start slicing your graphs of your functions with horizontal planes. So what you're doing is, imagine a watermelon, and you take a sword or a chainsaw and just go horizontal, slice, slice, slice. Order those slices at z equal 1, z equal 2, z equal 3, z equal 4. what is the shape that you get at the edge? Obviously, in the case of watermelon, it will be ellipses. But then what do you get as you slice different objects? If you take this cylinder, put it down, slice, 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 every inch, let's say, I wanted to say centimeter, but let's go with inch. Make a slice every inch. So bottom is z equals 0, it's resting on the table, and then every inch is z equals 1, z equals 2, z equals 3, z equals 4. Every single slice, well, this is a cylinder. What is it going to be? Circle. So you're going to have circle. Now what? Rectangles, right? So that all of the level curve cuts are going to be horizontal cuts. Always make sure that your floor is z equals 0. And then z equals whatever the step is. You can cut every inch, you can cut every mile, you can cut whatever it takes. It's a very useful feature. You'll see why. But right now, I just want to write let me see. All right, so let's take a look. Actually, I have to bring up the textbook because of the I have this is the one where I have to show in the just give me 10 hours. All right. So the next part is this talk about level curves. Observe that you have this shape, whatever the equation for this is, z equals f of xy, and this is what you get. Think of it as a sand pile or whatever. And as you can see, the cuts are being applied to it, and then you are looking on the graph on the side, which is the xy. So all of these lines, the contours that are intersection between the shape and the plane that cuts, are now drawn on xy plane. So at the top, there's going to be a 0, which will just give us a dot at the origin. And as you start cutting down, it just gives these concentric circles or ellipses or whatever they are. And you can see that they are all equally spaced on either side, which tells us that this object is radially symmetric. And it goes, it's pretty much the same from each side, no matter which way you look. Then we go to the next object. Maybe, there we go. And now you have that parabola that we talked about earlier. Thank you for submitting the class prep because I get to use it now. So it's slanted, right? That's the shape you have over there. Just this, we had it, and now I'm just gonna lift it up a little bit so on the side is slanted. And now as you cut it horizontally, you see that it creates these lines. Now, it's crucial to see the object and start thinking about it. Look at this, guys. Is it easier to climb to the top, which is right here? Is it easier to climb to the top on the sides or from this on the edge all the way forward? It's easier to go on the edge to the top rather than climb any of the sides, because the sides are steep and the edge is not steep. It is, but it's not as steep as the sides are. You can see that from level curves. You see that the approach here, the level curves are far apart, where over here are very close by. That means that the approach from the sides is going to be much more steep than the approach going on the edge. Now, where would such a knowledge be very useful?
Architecture.
Architecture, all right. Map making, yes.
He said cartography.
Yes, cartography, yes. So, when you, one day when you are on that desert island and you find the map, obviously you'll know how the topography of the island looks like, right? You won't be lost. But let me find, I think they have a map somewhere in here. Do they? There it is. Well, come on. Now, looking at the map, you see how busy the map is with all these lines. So, the lines are the level curves if you are to take plains and cut through hills and valleys and so on. So now, the closer the lines are, the steeper the sides are, and that's why you send the rock climbers and people who like those kind of things. My area, right here. Look at that. They're wide, that means it's flat. You can lay down anywhere. It's awesome. All right? Now think about this application. You're in an unknown territory, right? You have the map. You know which way to drive if you have the off-road vehicle. There's no road, right? Obviously, you can't do something like that in the desert because the wind moves things all the time, so maps are outdated quickly. But in this case, right, where the mountain is going to stay where it is, hopefully, you know that if you want to get from this point there, you should go that way, because these guys are far apart. That's not steep at all, right? Then you have to go this way because this way is very steep, and then you're doomed right there because that's steep, that's steep. So this way, then drive straight through, follow the level curve a little bit, and then good luck with this part. Then you jump. I don't know. But it is important to learn how to navigate these maps. I don't know if you're in the military or whatever. Where to land the plane? Like hopefully right here this way, all right? Because that is, yeah.
I mean, if you line up the center of mass, you should be pretty okay. Just be careful when you get to step out. You can do it. Be careful.
Yeah, sure. Just make sure I never get the advice from YouTube. Okay, so the level curves, now calculations. Calculations for level curves are insanely easy because all you are going to do is cut with planes z equals 0, z equals 1, z equals 2, and so on. And if the plane z that you are trying to use is not giving you good answer. That means that you are picking a bad value for z because function doesn't exist on that elevation. So let's see an example. Earlier, I had z equals 4 minus x squared minus y squared. So I already did z equals 0, which gave us eventually x squared plus y squared equals to 4. And we know that's a circle with radius 2. And then what happened is, let's try cut with z equals 1. When you cut with z equals 1, you are just plugging that into original problem. You get 1 equals 4 minus x squared minus y squared. And then when you move things around, you get x squared plus y squared equals to 3. Well, that's just going to be a circle with the root 3, so that's inside. Root 3 is about 1.7. Then you try z equals to 2. Z equals to 2, again 2, and then 4 minus x squared minus y squared gives you x squared plus y squared equals to 2. Well, square root of that is root 2 is 141, so another circle inside. Z equals to 3 gives us x squared plus y squared equals to 1. Z equals to 4 gives us a 0. X squared plus y squared equal to 0, and that's a point. 0, 0 is just the origin. And then here it is, z equals to 5. As soon as you plug in, for this particular problem, as soon as you plug in z equals to 5, the problem explodes. Because you get x squared plus y squared equals to -1. Hold on, any number that is squared is positive. When you add two positive numbers, there is no way, comma, in hell, comma, to get a negative number. So, I can still talk before I click. I'm making a point, of course. The software senses it when every time when I'm excited, it immediately, checks out. So the progression goes, and now we have the two positive number adding to a -1. That means that the plane you chose to cut through the object doesn't actually cut the object. It misses it. So there is no level curve at -1. Now I can restart the program. And we'll be good to go. There we go. Now you can pick z equals negative whatever for this particular, and you will be getting bigger and bigger and bigger circles because any negative number will add to the 4, obviously, and we are going to get larger circles. So you can see that it starts at 4 and then has this circle, right, going down, making it larger and larger and larger. That's how you calculate. So now the question is just how annoying is the shape and how much calculation you have to do, and do you know how to graph functions that you get or shapes that you get? Circle is not a function, right? So it doesn't have to be a function. But that's the level curves. It's a really quick z equals kind of deal. Now, here is another one of the same sand pile or whatever. And you can see more cuts and more circles. I think there are, look at that one. Just parallel lines. But it's a wavy thing when you see it up there. That one better have some sign in it, because when I look from certain angle, it does have sign. That one is cool. Aha. So how about that? Electric potential function in 2 variables. Where are my electrical engineers? Yeah, they're like, we need to know this? Yeah, give it like 3 months, you will. This is how electrical engineering looks like. 78% mathematics, and then you have another 22% of math after that. That's electrical engineering. So it's much easier to understand this if I say, yeah, termite nests or houses or whatever. I make this. So you see how steep those edges are and how close to circles are. And then when you go to the base, they get further and further apart because the base tends to be flat. Functions on more variables, I already talked about it, right? You can have any dimension you want. And as I said, every time when you are considering more than 3 dimensions, just think what other qualities are there to the shape that you are considering. Because for this particular shape, I can talk about its temperature distribution, but I can also talk about its density, right? There are other aspects of the object other than just its shape that you can express through mathematics. I think they have a very nice photo of, there it is. Oh, yeah, that. Temperature distribution. This is how you graph 4-dimensional shapes. You actually have a 3D object as is, and then you use colors to give the scale from cold to hot or from low to high, right? From blue spectrum to a red spectrum. If it's a temperature, you say, all right, well, I know red is hot and you know, blue is cold because I take shower, right? So, but you can also think of that as blue being a low value and red being a high value, and then just apply density to it. So the object is going to be more dense whenever it's shades going into red and less dense going into blue. So, you know, you use the color to give the scale for the 4th dimension, because you can't really, you know, graph. Guys, this is a 4-dimensional graph on a 2D surface, right? That's what it is. And it represents a 3D shape. So it's a 4-dimensional representation of a 3-dimensional graph on the 2D surface. See that? That's what it is. Yeah, think about it a little bit. You'll see it works. So the 4th dimension is captured by colors. And then you have homework exercises, and that's it. So I hope you're not disappointed, but that's what we have. We defined a function. We talked about the domain and the range. We talked about the how to graph the functions by looking at side cuts. And then we talked about horizontal cuts that produce level curves, and then how those level curves, the separation between the level curves is telling us a lot about how steep the object is, and so on. So that's it. And let's do the review for the exam, and then we'll continue the lectures tomorrow after the test. Just say bye over here. Bye.